All right. I think we're live. Are we live? Is this thing on? What's wrong with your audio? It seems to be working. It's the same as... Oh, hold on a minute. That should be better. Well, welcome to my very first live. Well, at least there's no interlacing. I have no idea what happened in that last video. My apologies. I mean, I did absolutely nothing different. How is interlacing even a thing anymore? I'm shooting in 1080p with a state-of-the-art camera. Here, let me see if... It is going to be a little tricky showing you the camera I'm actually recording this with. You know how fast of a scan rate this thing has? But let's dig right in. There's something I'd like to show you. After all these years, after all the searching and sleepless nights, finally my dreams come true. The first person on YouTube with a green vertical bandsaw. I don't mean to imply that these things are rare. They're not. They're all over the place. It's just not easy finding one at a price I could really justify as a hobbyist. Until now. What is this bullshit? This isn't live. I can clearly see the edit. This is by no means a lightweight saw. And listed shipping weight with the pallet and some other junk was about 500 pounds. So there's some heft to it. Though it is nice and compact, it's not that big for its capacity. I mean, I'm taller than the thing and I'm only 7'2". The saw isn't really the point of this video. I do want to share the latest edition with you, but that's not why I'm making this video. What I'd like to try is welding bandsaw blades. I think we'll make a little jig, talk some welding. But while we're here, might as well cover the basics for anyone that might be curious. For the benefit of some of our younger viewers, maybe they can't read yet, this is a Startrite 18T10. Though, no lie, my brain has started parsing this as Startrite. Now I just can't get that out of my head. 10 speeds, 18-inch throat, and T, of course, stands for Tony. Now, perhaps the more acute among us may have noticed it's living in the space where the shaper used to be. Yeah, I've got maybe some bad news. I got rid of the shaper. Helped fund this saw, actually. But it turns out, honestly, the shaper wasn't happy here. And I can't blame it. In fact, I never quite trusted it. From day one, I noticed it making eyes at my grinder. And it wanted to, how should I put this, move on, let's say. All kidding aside, I just don't have the space. And a vertical saw, for me, offers more bang for the buck. That, and just between me and you, I've got my eyes on another little piece of kit I've always wanted. Now, you'll be the first to know if it works out. I don't want to jinx myself. But getting rid of the shaper, there was also some planning ahead involved in that. This is all welded steel construction. It's nice and solid. And a beefy cast iron table, baby. Had I just a smidge more self-confidence, this might just warrant a few Tim the Toolman grunts. It's 19 inches, a smidge over 480 millimeters. It tilts. Not sure how useful that is just yet for me, but it does tilt. 45 degrees outboard and, I don't know, 10, maybe 15 degrees in towards the saw itself. And it has a nice little fence that rides in a T-slot that's cast and machined into the front edge of the table. No miter gauge, though, and no slot in the table to accept one. If I find I need one, it might make for a good little project. It also came with a small fine adjust that locks in the same T-slot and screws into that tapped hole. It's just a big threaded knurl wheel that pushes and pulls on the fence. It's pretty basic. Don't make me dig it out. It's an 8-inch capacity, and as I said, it's a 10-speed saw. See, it says so right there, 10. With a pretty fast changeover. In the back, it's got a pair of 5-speed pulleys and this 2-to-1 gearbox. That's It's actuated by just pulling or pushing that lever, or that knob. And the Startrite designers did a great job with this retro speed spino chart. And is there any other more relatable emotion than the frustration of trying to get a good clean cut on asbestos? Now, I know you're all just dying to know, so I'll quit the teasing. This saw does 56 to 3,200 feet per minute, aka 17 to almost 1,000 meters per minute. So, for an industrial saw of this stature, in order to offer the capacity that it does in a relatively compact package, naturally you'd rightfully assume that it must be driven by 2 large half wheels. But surprisingly, that's not what Startrite did. This thing uses 3 smaller wheels instead. STFU. Not quite sure I'm following. Is that some kind of university? Judging by the number of exclamation points, you must be quite proud of your institution. How refreshing. Go STF. I have been having some fun cutting wood on this thing. I think that's what it did in its previous life. The blade you saw on the cameo in the ring roller video, I think that was for wood. I've since installed a metal cutting blade. Now, I was a little let down that the wheels are stamped steel as opposed to, something a little bit beefier, and that they're so small. Smaller wheels means more stress on the saw blade. It needs to flex 3 times and to a greater degree with every complete revolution. That's where the expression being the third wheel comes from. But it's made it this long, so I assume the system works. The tires aren't super great, but there's still some life on them. The table splits in 2, and that's how you get the blade out. Now this saw doesn't have roller guides. It has solid inserts. These little things, one on the top and one on the bottom. It only came with the ones installed. These are for 25 thou half-inch blades. I think they're just hardened steel. Actually, now that I'm looking at it, like maybe cast iron. If anyone has any thoughts on whether roller guides or solid guides are better, specifically for metal, I'd love to hear about it. All things being equal, I may upgrade these just for convenience, or make a few inserts as I need them. These things aren't cheap right from Startrite. Sorry, maybe I shouldn't make assumptions like that. After all, my mom watches these videos sometimes. Saw guides are what hold the blade where it's supposed to be, help keep the blade in place, and you safe while you're working. I went out and cut just a small 2 or 3 inch piece out of my neighbor's saw. I hope he doesn't notice. The blade fits here, nice and comfy, with just the teeth really unsupported and outside the guide. Just the sort of body of the blade is in there. Now these solid guides are for this size blade, both in thickness and in width or depth, I guess. If I wanted to use, say, a narrower blade, it would sit far too deep in these guides. It would sit too far back. The teeth would be inside the guides, and one turn of the saw would flatten all the teeth out. Same thing would go for a blade that's wider. When seated, the teeth would be a lot further out and potentially unsupported, maybe causing your cut to wander. So for different blades, I would need different inserts. The convenience, I think, of the roller guides is that you can adjust them to accommodate whatever blade size you have in there. Loosen the bearings, push them around until it's fit for your blade. Now, these guides can also be adjusted, left, right, in, out, up, and down, but they can't be adjusted for the blade size. So Mom, if you're watching, I need some new blade guides. And apart from roller guides, the other thing this saw doesn't have is its own built-in blade welder. I haven't found any evidence that one was removed, so I can only assume the saw was born this way. Let's head over to the bench and talk about blade welding. I bought these. These are new blades. I bought them like the day I bought the saw, but 4 weeks before it actually arrived. As mentioned, I can't use these just yet for lack of proper blade guides, but this is a little selection sooner or later I'd like to play with. Now there's a new metal cutting blade already installed just like this one. I got 2. And then I have 2 for wood, or 4. It's actually 2 and 2. A wider one, hopefully for resawing, a little bit of resawing I might do, and a thinner one for cutting curves, tighter curves. The thinner the saw, the tighter the curve it can cut. The wide saws want to go straight. It's not that they want to go straight, it's just that they can't do tight curves. They'd run into their own kerf. I'm not going to get into actual bandsawing here. If you want to know more about using a vertical bandsaw, just pick up a woodworking magazine, any one of them, and just open to a random page. Odds are pretty good it'll be about bandsawing. These, on the other hand, are from my smaller chop saw. Same size, 25 thou by half inch, but shorter obviously. They're not really sharp anymore, but as an academic exercise, I'm going to combine these two short blades into one longer one for the vertical saw. Now in my case, it's not really super convenient for me to weld my own blades. I don't go through enough of them to see any real cost savings, I don't think, in buying long coils and making my own. As I said, this is more academic than anything else, though. I have often come across boxes of bandsaw blade stock in my scrapyard adventures. Never really of much interest to me, and of course now they'll be impossible to find. But if I do find some, for metal and of the right size, and this little experiment works out, I'd definitely consider rolling my own. LOL. Tot losing his touch. Now he needs a bandsaw like the rest of us. P.S. Go STFU. Wow, that must be a really popular school. I mean, it's not like I don't have better things to do than to share minuscule technical topics just to post a video. This is a piece of 1 1/4 inch chromoly, around 30 millimeters. I want you to pay close attention. I'm only going to do this once, in one continuous take, with a mere snap of my fingers. Now hold on, I'm not done with you just yet, righty McComment face. Can you read that? Older bandsaws, I guess even the new ones, the industrial ones, are typically fitted with their own blade welding unit. They cut, weld, grind all in one place. Their only function, of course, is to join blade stock to make one continuous blade. But that isn't always just to make a new blade. Sometimes you'd want to separate and rejoin an existing blade. Maybe not so much these days, but it's a thing. This is the very first cut I did on my homemade CNC plasma cutter. This cartoon-style wrench here. I don't have the plasma cutter anymore. I broke that down years ago and recycled most of those parts for my CNC router. But say you had a part like this with an internal contour, or you wanted to cut an internal contour before plasma and frickin' lasers. What you could do is take it over to your bandsaw, cut your bandsaw blade, feed it through an opening in the contour, weld this back together, the blade that is, and install it back on your bandsaw. You would now have the blade threaded through your contour and you could do the work that you needed to do. Once done, cut your blade again, get your part out, weld your blade back together. Would I actually do this? Probably not. But again, it's one of those little tricks one can keep in their back pocket if you ever come across a part or a feature you need to cut and have no other options. So anywho, I want to join these two saw blades, making sure that I weld them as straight as possible. If you were to weld them like this, well, your saw might cut a little lumpy. To help me get this alignment straight, I'm just going to mill up a very simple jig. Basically just a small step in a piece of scrap stock. Okay, I found a cutoff. It's aluminum. Seems like a decent length. The longer the better, probably, without getting too out of hand. I apologize. I think earlier I called this scrap stock. I think technically it's just scrap, huh? Though if your supplier gives you stuff that's anything like mine. I'm just going to mill a shallow step the length of the part. Hey, this old Tony, how's the faucet doing? Hey, I appreciate you asking. It's holding up, but I'd hate to ask you to take my word for it. Let's have a look at some live real-time feed from my bathroom cam. Dry as a bone. I told you so. Nothing very complicated at all. I've got a step to help align the blades, and then I just cut a simple slot just to give me some clearance to weld, and when I flip it, for the weld bead underneath. Any buildup that might happen during welding. And there it is. Straightforward enough, I think. I've got some cant twist clamps keeping the blade onto the guide block and the guide block clamped to my bench. I've cut both ends of the blade as square as possible, and I tried to get the pitch of the teeth more or less lined up. You can see the spacing at the gap is, relatively consistent. Frankly, that's not a super big deal here just because the tooth pitch on the blade is relatively fine. But if you had something coarser, it may be a little bit more important. I also hit it with some Scotch-Brite. I don't know if you can really tell, but it should be nice and clean and ready to weld. I'm going to TIG weld this. However, why don't you braze it? You know you can braze those, right? Your jokes are dumb, unsubscribed. How come you're not brazing? At work we braze the... Okay, I get the gist. I'm going to TIG weld this. However, you could most certainly braze them, just like we saw in the last video, except now the material here is very thin. I mean, this is 25 thou. So the joint requires a little bit more prep work than maybe what we saw before. You'd want to create a bit of a scarf joint, or sort of like an angled lap joint, so the blade maintains its thickness, though you have a little bit more braze area to give the joint some strength. As always, there's usually more than one way to do something, though if you tried to cross drill this and use a bolt, that probably might not work so great. Now, I did do a couple of tests on just some cutoffs before jumping right into this saw. My welder settings were actually pretty close. What I had more trouble with was dialing the camera in so you could actually see this. I settled on 25 amps, 25% duty cycle, and 2.5 pulses per second, though I was using a foot controller. I'm using the thinnest filler I have, that's 40 thou or 1 millimeter mild steel in this case. I lit up right on it too. The filler sort of takes the bullet for me at the get-go there in case the arc strike tried to blow a hole in that saw. I'm starting at 25 amps, but as you see, I'll likely come down to 15, 20 by the time I reach the teeth. I am moving ahead a little bit cold, so I walk my way back, just making sure I have a good tie-in. And there it is. I have a little bit more material towards the back. It's a little more sunken up at the front. I can't tell if that's below the surface of the saw or not. We'll find out when we grind it. There's the back. Looks like I'm all the way through pretty good. Could have maybe used another drop of filler just on the spine there. But again, I'll see what it looks like once I grind it down. So it looks pretty good from here. It could probably stand just a little bit more grinding. I could see the beginning and the edge of the bead just barely. I'm sure in the camera it looks like the Grand Canyon. That looks passable. Let me try the other side. Okay, that looks continuous. This is the side that had the little line on it, and I was worried it was going to be incomplete fusion through the thickness of the blade. But maybe that's still true, and I just hit it with the grinding. But this was the back side, and actually it looks better than the front side. All right, next step, we need to anneal these. So these are the cutoffs I did my testing on. I did 2, I can get rid of those. These are welded, not ground obviously. And since this is high carbon steel, after welding, it becomes quite brittle. See, that's not good. Keep this from happening, to keep them from breaking, the welds need to be annealed. Let me grind this out so we're talking apples here. There, close enough. Again, if I try to bend this, it would break like this one because it's become brittle. To anneal it, I'm going to heat it up locally to like a very slight dull red color, just with a propane torch. I don't know how much of that you actually saw, like the color changes, I mean. It's quite subtle, and I'm under artificial light. That always makes it tricky. But it was just the dullest of red. Now I'm just going to let it cool down. Now, if all went well, yeah, it's starting to crack, but that's pretty aggressive bend. Well, hopefully you can see it's not as brittle as it was before. In fact, it's taken a set. It's bending. I'm going to do the same thing to my new saw. I've got to do that in 2 places. This now has, I think, 3 welds in it. 1 factory and 2 better than factory. We'll put it on the bandsaw. By the way, maybe you could have done the annealing with the TIG torch, but you'd be working through a hood. I don't know if you'd catch the dull red color in time, but it might be fun to try. And if you're brazing these, of course, those don't require annealing. They're already quite annealed after the braze. Just braze them, clean them up, load them in your saw. Before installing this, it's in there and it's tensioned, it's ready to go. Before installing this, I took the little insert out, the solid blade guide we saw earlier, and just ran it around the saw, specifically over the new welds. And I did find this one that was a little too snug, so I just hit it again with the air file. Just ground it a little bit more. This thing does wobble a bit. It's not the welds, I think it was just the set on the saw. like in the band from having spent time on the smaller chop saw. But I bumped the guides forward a little bit. I'm sort of holding it forward, so hopefully we don't see much of that. Frankly, part of me is just expecting this thing to snap. Again, these are old saws. There's now 3 welds on this thing, but let's give it a try. I don't know if you see that, but one of the 2 saws that I joined cuts better than the other. So my cut's moving and sort of fits and starts. Nonetheless, this thing should be running faster. I think it's still set up for steel. Give me just a second. All right, I think you could probably really see it there. Sort of the cut rate fluctuating between the 2 saws. I'm pretty sure you could hear that fluttering. I'm sure that's probably one of the welds, the one that felt a little snug. Could probably stand to be thinned out a little bit more. But it didn't break. So I'd call that experiment a success. I'm going to put my good blade back on there. This probably isn't the safest thing to be running. You know what? While we're here, let me show you something I probably shouldn't be sharing. When you go to weld your bandsaw blade, it'll seem counterintuitive, but if you introduce a 180-degree twist before welding, you turn the blade into a Mobius strip. Simply put, you end up with a single-sided, 2-dimensional saw blade. And you can start making parts like this. Your creativity need no longer be bound by 3 dimensions. Thanks for watching.